In this tutorial, you will make this power piston assembly. You will create each individual part, including the small and large pins, piston, connecting rod and flywheel. We'll assemble all the parts and then verify the assembly by creating a motion study. Let's do it. So the first thing we're going to talk about with this tutorial is in previous tutorials, we have done something called in-context design. Or as you can see in our browser, we have created two parts within our assembly and have done that within one project. But with this tutorial, we're going to do something a little bit different. Sometimes we don't have the luxury to create an in-context design. We might be given files from an outside source and have to input that into a project and then model around that file. Or we might have to input several models that have been sent to us and create an assembly based off of those files. So we're going to take that approach today. So let's open up a new design, and we're going to save everything under one project. And here I've named the project Power Piston Assembly Tutorial. So when we locate that folder, all of our projects or all of our models will be saved within this particular folder. And then we'll create a master assembly file where we will input all of those individual files into. So let's get started with the most simple aspect of this assembly. Let's first of all create our pin. So let's save it and call this pin small. And this is very simple. We'll create our sketch on our YZ plane, center diameter circle. So it'll be 0.5, finish sketch, and we will extrude this 1 inch. And that's it. Let's save it. You can see as we save it, it will be located in our folder under Power Piston Assembly Tutorial. So now let's create our large pin. We'll save it. Pin large, and for the rest of this tutorial, or most of it, I'll just leave the browser up here on the left. So here we'll create another sketch on our YZ, and this one's going to be 1 inch in diameter by 1 inch long. So E for extrude, let's just do that, and we'll go the opposite direction 1 inch, and that's it. Now let's do our next one, which is our cylinder. So sometimes if our part doesn't show up here on the left, which we have just saved, we can refresh it, and it should show up on the left. So let's save this as our cylinder. And again, we can create our sketch. Now this one is 2 inches in diameter with a bore set at 1.5 inches. So we can finish that sketch. And now we can just extrude that outer profile. And this is going to be 5 inches long. And that's it. Let's save. Next, let's do our piston. This is going to be a solid body on our YZ plane of 1.5 inches. And we can extrude that -5. And let's create another sketch on our front face. Make sure not to pick the YZ plane, but the front face of our cylinder. And we'll create a center rectangle off of our center point. And this is going to be 0.5 by 1.25 tall. Finish sketch. Now we can extrude that profile. This is going to be 1.5 inches long. So for this, we can create a fillet and make sure to select full round fillet. Now you can see as I hover my mouse over the face here, the side walls turn blue. If I were to click right now, the fillet is created in this direction. So that's not good. So all we have to do is move our mouse down, and you can see now our blue faces are going to be on the top and the bottom. And if we select, we'll create a full round fillet from top to bottom in this instance. Let's go OK. Now we can create the hole in the middle here. Let's create a sketch there. Now we can just create a center diameter circle. And again, we can use constraints to make sure that it is perfectly placed right in line with this fillet, or we can say concentric within that fillet. But just to show you how easy it is to create using constraints, let's just create the circle off of here, our bore of 1/2 inch. And then use the concentric constraint. So we'll click on that, click our circle, and then just click our rad here. And there we go. It's perfectly placed in line or concentric with that profile. Let's go finish sketch. And now we can extrude this. Make sure to go to object, and we can just pick the other side of our piston there. Okay. So now we can go up to fillet and make sure to select our regular fillet. And now we can actually select this entire face here and just put a tiny, let's go a 10 thou, maybe a 20 thou on there. Perfect. And we are good to go. Why don't we add these two as well? Okay, now the piston is finished. The next is our connecting rod. So let's save that right away and call it connecting rod. So the first thing we can do is create a sketch. We'll create it on our YZ plane as well. And this is going to be a center rectangle. This is going to be 1 inch high by 0.5 wide. And we can extrude that. This is actually going to be a calculation. We can go 9.625 minus 2 inches. And a good thing to remember while we're modeling is do all of the primitives or primary shapes first, and then do the fillets and the rads and the holes at the very end. So let's do the other side of our connecting rod here. We'll create a sketch on this face and another center rectangle. This is going to be 1 inch wide by 1.25 tall. And it's actually going to have a 1/2 inch spacing in the middle. So we can just put this at any distance as well and then constrain it later, or we can just specify 0.5 right there. Now you can see that there's blue lines up here, and that's because it is not constrained. So if we hold down our left mouse button, we can pick that individual line, and there we go. You can see it's not constrained. So if this happens to you, it's best that we create a collinear constraint between that line and this, and then everything will turn up black. Now this still has not been constrained. I didn't specify a dimension for that, so let's just go D. We can pick that edge, and call this 1 inch exactly. Let's finish our sketch. Now we can extrude it. So let's extrude this. And actually we'll extrude all of these. And this is going to be 0.375. Now we can bring up that sketch that we just made, because we're going to extrude just those outside profiles, and we can hide our body there. Let's just extrude those outside profiles, turn back on our body, and these are going to extend 2 inches, and make sure that our operation is not set on cut, but rather join, and that will join everything together. Let's go OK. Now that we have our primitive shapes, we can add our fillets. So let's go there, fillet. And we can go full round fillet like we've just talked about. We can select that. I'll have to add another selection set right there. And another selection set on this side. And make sure to hover our mouse so that the blue faces go on the top and the bottom. There we go. Let's go OK. We can hide our sketch now over here. And all we have to do is add our holes and then some of our tiny fillets. So let's do that. Create sketch on this face. Again, we can create a circle off into space. It can be anywhere really. This is going to be 0.5, and then make it concentric to our profile there. Let's finish our sketch. And I like to create all my sketches at the same time if possible, so I'll select that face as well. We can also just select our circle, hover over that, and you should be able to see a little circle symbol show up. And this is the center point of our rad. And as you can see, the concentric symbol shows up there, which means that our circle is perfectly concentric with our outside profile here. So let's go finish sketch. And now we can extrude that and go to object, which is the other side of our connecting rod. Go OK. And we can do the same thing here. Pick that, distance to object, the opposite side, and go OK. Now let's just add a couple small fillets. Make sure to select our regular fillet there. And again, we can pick that entire face, and we'll call that 25 thou as well. And why don't we pick all those? Perfect. And these ones as well. Okay. Now last but not least is our flywheel. So let's save that as our flywheel. And this, I think, is the funnest part of this project. So let's create our sketch now on our XZ plane. We'll create the outer profile of our flywheel first, which is 4 inches. And we can actually create all of our different profiles at this point too. So our center circle is 1 inch. And again, to select the previous tool that we've just selected, we can right click and there we go, repeat center diameter circle. Now we want to create a through hole over here. And as we select our x-axis, we can just snap it right to that. This is going to be 0.5. But as you can see, it is not constrained to anything. We can move that. So we have to make sure that this is fully constrained. We can do that by selecting the horizontal vertical constraint. We'll select the point there and our midpoint. And now all we have to do is a dimension from our center to center. And this is going to be 1.5. And it should turn black now, fully constrained. So we're going to do the same thing on the other side, which is going to be our wheel. This is going to be 0.5. And we'll make it the same spacing from there to there. We can actually just select our dimension over here to input it into our current dimension. So let's do that. And you can see that it is not constrained. It's still blue. And which direction does it need to be constrained? Well, you can see as we move it, as we click and move it, it often gives an indication of what needs to be constrained. So let's just pick our horizontal vertical constraint and we'll pick the 2 center points. And there we have it. So let's finish our sketch. Now let's extrude these 2 profiles in this direction, and it's going to be 1/2 inch. We'll bring our sketch back up because we want this profile to be going the opposite way. So we'll pick that and we'll go opposite minus 0.75. And we're going to add a little taper angle to this. Let's go 10 degrees and it puts a little handle on there. So let's go OK. And we could also put some fillets on there if we wanted. Let's do 1, 2, 3, 4, and call that 25 thou as well, and save. So you can see that in our data panel, we have all 6 files that we've just created. So now we can create our master assembly file. So let's do that. We'll create a new design, save it, and this will be called Power Piston Assembly. Let's go save. So now we just input one of these files or projects or models, we could say, at a time into our master assembly. So let's start off with our cylinder. So we're going to right click, insert into current design. We've inserted our cylinder and we can go OK. We could move it if we want or orient it if we want, but let's just go OK. Now we actually want our cylinder not to move at all. So let's just right click that cylinder and ground it. If we don't ground it, it's going to be flying all over the place as we move our piston assembly. So the next thing we want to do is input our piston. So here we have to make sure that our assembly is activated. If we have a large assembly of many different parts, we may at some point activate an individual model. And as we insert a new model into the design, it will actually put it underneath that model rather than underneath the assembly file as our parent file. So just to keep that in mind, if I do it accidentally or if I have an opportunity to show it, I will. But let's just keep on moving here. So let's go to our piston now, and we're going to right click, insert into current design. And it's actually positioned exactly as we want because that's how we've designed it. So let's go OK. But if, for example, it's not positioned exactly where we want, maybe it's off to the side or something like that, we will have to join it. Or we're going to have to join it anyway. So why don't we do that right now? Let's go join. And remember the fundamental rule, this to that in Fusion 360. So the first component that we pick is this, and we want to move it to that. So this to that. And that's why our cylinder turns up transparent. We can't actually select anything on it because we can't move that. That kind of gives you the indication of which component needs to be moved first. So we need to snap a point on this to a point on our cylinder. Now I kind of want to snap the center point of this face to the center point of that face. So let's do that. And this is fundamental. If you can really pay attention, some of my students just don't understand this concept. And I'm sure that others don't understand it out there as well. So here we want the center point of this face. And as we move our mouse over, you can see it selects this face instead. But no, we want that center point. So how do we do it? Well, there's 2 ways of doing it. We can select our face, we can click it. And there, now we can pick anything on that face without it selecting anything else in our model. So we can do it that way, or we can simply hold down Command on a Mac or Control on Windows, and you can see it does the exact same thing. We can pick any point on that face that we have pressed Command or Control. So we can do that, select that point. Now that turns transparent, and we can do the same thing over here. This we absolutely need to do. I'll do the other method. I'm going to click on that face, and now we can select the center point. So you can see Fusion says, well, this makes more sense if we orient it like that. Simple, we can just flip it, and now our piston and cylinder are properly jointed. Now we want to make sure to add some motion to this. So let's go to motion, and our type is going to be slider. And you can see it's sliding in that direction. That's great. It might be the opposite axis that you've picked, or it might be another axis that you've picked by mistake. So if it is, don't worry, just go down to our direction here and make sure that the correct axis is selected. Now we can also add a custom axis if we want, but in this case, one of the three will work. Now we want to add some motion limits to it as well. Our minimum is going to be 0. Our maximum is going to be the length of our piston, which is 5 inches. Well, we shouldn't actually do all the way to 5 inches. In real life, that wouldn't work. The piston would obviously fall out. So we're going to go to 4.75. There we go. And our rest is going to be back at 0. So again, this is the default position of our piston and cylinder. When we hit OK, even if we are off into space over here, oh, there we go. So as soon as we hit stop, it will go back to our rest position, which is at 0. Now the next thing we're going to do is add the small pin over here. So let's go there, insert into current design, and we're going to move this small pin off over here. We don't actually have to orient it right now. We can if we want, but I'm just going to leave it at 0 degrees just to show how easy it is to join two components together. Let's go OK. So let's joint, and we can snap our first pin over here to our piston. So as we hover over a cylinder, you can see that we only have 3 snap points. We can't pick anything on the diameter because the diameter has an infinite amount of points. It doesn't know which to snap to. But as we hover over the center of our cylinder, there we go. We have a center point that we can snap to. So let's do that. And we can snap to the center point over here. How do we do it? Well, same principle. We can hover our cursor over that cylinder, press Command or Control, and now we can select that center point. Remember, we can pick any snap point that's found on that. So we want to go to the center and click it, and look at it automatically orients our pin in the correct orientation. Now, obviously, we don't want a slider motion to exist here. So we want to change this back, and we want to turn it to revolute. And here you can't see it doing anything because it's a round object, but you could see that little wheel, the motion limit wheel here, spin. So this is perfect. We can actually go preview motion, and there we go. We see that our pin is revolving 360 degrees, no problem. Let's go OK. Now let's assemble our connecting rod. So right click, insert into current design. Again, here we're just going to move it off into space so that we can see it a little bit more. And now let's go joint, and we're going to choose a different type of joint here because as I hover over this cylinder, you can see that our center point, we want the center point between both cylinders, right dead center of the connecting rod. So how do we do that? Well, this is quite easy. You can see under our origin mode here, right now we have simple selected, but we want between two faces. And just look at our little dialog window, creates a joint origin that is centered between two selected faces to position components. So let's do that. We're going to select that. Now plane 1 is going to be this plane or this face, and plane 2 is going to be that. And now it asks for a snap point. So we can hover our mouse over here and select any snap point we want. So again, we're going to hover over that face, hold down Control or Command, and then pick the center. And as we do, I'm just going to orbit a little bit there. As I do, you can see that the center point is right there. So we're going to select that. And your center point should be right in the middle of your 2 bored holes there. So now we can select for component 2, the center of our pin here. So we're just going to hover over the pin again, hold down Command or Control, and we can select any of those points, the outer points or the center. So let's select the center. And revolute is on, which is great. Let's go OK. And the motion can be infinite. We don't have to worry about that. Let's go OK. But try and make sure that our connecting rod is perfectly in line with our piston and cylinder. That's going to save you a little bit of aggravation later. So let's keep on moving here. Next thing, we're going to add the next pin over here. Let's do that. Pin small, insert into current design. So you can see we actually already have a pin small. Well, that's okay. That's the brilliant thing. We can keep on adding pins to this, as many as we want. So let's go over here. We're going to do the same thing. Joint it, midpoint. I'm going to hover over the cylinder, Command. There we go. And it's already on revolute. That's what we've been using. So let's go OK. Now we can add our flywheel to the mix. We're going to bring this over here. And we actually want to rotate this now, 180 degrees. And we're going to connect this hole to that pin. So we can join it. There we go. And actually, we don't want to pick the middle point. We want to pick this face right there. And we want to connect it to that. We can flip it. There we go. And the only problem is I actually put this pin in too far, but that's okay. Let's just go OK there. We're going to go back to our previous joint. And instead of connecting it to the center point, let's just reselect our points that we want to connect. We want to do the end point and not to our center of our cylinder, but we can actually go over here. Oh, so in this case, we actually have to use Command or Control. There we go. And flip it. And your pin should look like that. Great. So now when we go back to our flywheel, we can flip this now. Well, let's just start again. There we go. So it's that surface. Perfect. And we can snap it to that. Excellent. So you can see now our flywheel is actually the wrong type of motion. We don't want our flywheel to move like that. So we're actually going to go OK. And we're going to add our large pin over here and anchor or ground that pin. So let's go pin large, insert into current design. I'm going to move this over there. Now we can join it, that face, to there. Make sure it's flipped. If we had it sticking out this way, well, then you could see it would actually smash into our connecting rods. So let's not do that. And we have to go now to our pin large and ground it as well. So now if we have designed everything and assembled everything correctly, we should be able to grab this handle with our mouse and rotate it. Let's see if it works. Well, there we have it. That's looking great. So we can just spin that. So at this point, we can actually test our joints by going to Assemble and Motion Study. Now I'm just going to hide the data panel there, bring our piston assembly off to the side. Now we want to select joints to animate, and we can expand joints there, go to our last one. And as shown in a previous tutorial, if you haven't watched it yet, it's on the top right of your screen. Please watch it to go into a little bit more detail of how to do a motion study. But we're just going to select on our final point here, step 100, and call this 360 degrees for our angle. Enter, and we can press play, and there's our motion. And if we want it to keep on repeating, we can select that. And there is our final motion. So hope that you have benefited from this tutorial. If you have, please consider liking and subscribing, smashing that notification bell. If you love our channel, please consider becoming a member or supporting us by hitting the thanks button just down below beside the like button. Anyways, hope that you are doing well. Thanks again for tuning into the Learn It channel. Looking forward to seeing you at the next tutorial. Take care.